Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 1, Probability, brought to you by Vitan Sir. Now, from the previous tutorials, we have studied the mathematical definition of probability, and based on that we studied some proofs. Now, depending on that formula, we will start with the exercise 1.2. Today we are going to do the first 5 sums of the exercise 1.2 step by step with the answers and the explanation. Question number 1. A balanced coin is tossed 3 times. Find the probability of following events. Now, in the questions of probability, whenever we are starting a solution, always start with the total outcomes, that is a set of the universe. So before we start, I am going to write down all the possible outcomes of tossing 3 coins. This is something which we have done before. We are tossing 3 coins, so the possible outcomes will be number 8. So always start with the total outcomes and then move forward with the events or the questions given in the sum. So the outcomes are HHH, HHT, HTH, THH, TTH, THT, HTT and TTT. Okay, I have followed a particular pattern which I already explained in the previous tutorial. Now, the first question here, getting all 3 heads. As you can see in the sample space, all 3 heads only has one outcome. So the favorable outcome here will be H, 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 that is 1. So the system is first write down the total outcomes and one by one find the favorable outcomes for all the questions. Okay, so the favorable outcome here is 1. The formula for probability is m upon n, that is 1 upon 8. So the favorable outcome is 1, total outcome is 8. So the probability of getting all the 3 heads is 1 upon 8. Simple. Number 2, not getting a single head. So if you check out all the outcomes, you can see there is only one possible outcome where we don't get a single head, and that favorable outcome is T, 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 that is again 1. So the probability here will be m upon n, that is 1 upon 8. Okay, so total outcomes are 8 and the favorable outcome is 1. Moving on to the third sub question, getting at least one head. So we need at least one head. So it could be one head, two head or three heads. So you can see I have written all the possible outcomes with at least means minimum one head, then two or three heads. That makes it 7 outcomes. So the probability here will be 7 upon 8. Next question is getting more than one head. Now the more than one head means we can't get 0 or 1 heads. We should at least get 2 or 3 heads. So we have to write down the outcomes which have 2 H's or 3 H's. So HHT, HTH, THH and HHH makes it 4 outcomes. So the probability here will be 4 upon 8, but we need to simplify because there is a possibility of simplification. So we divide 4 and 8 with 4 each, so it becomes 1 upon 2. So the probability of getting more than one head is 1 upon 2. The fifth question is getting at the most one head. At the most means maximum 1 or less than that, that makes it 0 heads. So 1 head and 0 heads outcomes are TTH, THT, HTT and TTT. Again the 4 outcomes, the probability will be 4 upon 8, that is 1 upon 2. That's the sixth sub question, getting less than 2 heads. Now less than 2 heads means actually the same thing, that is 1 or 0 heads, but not 2 because it is less than 2. So the favorable outcomes will be just same as the fifth question, and the probability will also be the same as the fifth question, that is 4 upon 8, 1 upon 2. We will take the question number 7. The sixth question was just changing the words, that's all. We have to think about logically. Seventh question is getting head and tail alternatively. So either we start with tails and get THT, or start with heads and get HTH. So 2 outcomes are there. So the probability will be 2 upon 8 and simplification will be 1 upon 4. Always remember, in the sums of probability, simplify them but keep them in fractions as far as possible. Don't convert them into decimals, unless and until the question itself was given in the decimals. Okay, so don't convert your questions in decimals. The eighth question and the last question of the first question, getting more number of heads than tails. Okay, so from the sample space which you have written already, if you check out, the number of heads should be more than tails. So that means 2 heads or 3 heads. So HHT, HTH, THH and HHH. The question will get 4 favorable outcomes. So 4 upon 8 will make it 1 upon 2. As you can see, the total number of outcomes remains same, that is 8 for each of these sub questions, because the sample space is the same thing. So the method of calculating probability, first calculate the total outcomes, then calculate the favorable outcomes, and m upon n, that is favorable upon total. Next question is question number 2. Two balanced dice are thrown. Now the question about dice is quite common. We have already discussed this in the exercise 1.1. Find the probability of the following. But before we start with that, we need to write down the 36 outcomes of the balanced die. Now remember, up to 3 coins and up to 2 dice, you must write down all the possible outcomes. More than 3 coins and more than 2 dice, don't write down the outcomes, just write down the total number. Okay, that I will teach you how to calculate. So I am writing down all the 36 outcomes of the 2 balanced dice, and I hope you guys remember how we drew patterns in this dice, which I am again going to write it down here, but I will not be explaining them again. If you want, you can get those patterns. The total number of outcomes here is 36. You can get those patterns in my previous tutorial, the first tutorial of exercise 1.1. Okay, so the patterns here is something like this. Sum is 2, the number of outcomes is 1. Similarly, I will just move on quickly through the patterns and the sums and the number of outcomes. Okay, but remember this thing, write this down in your notebook right now, because the next questions will heavily depend on this particular system which I have drawn here. So if you don't write down this system in your notebook right now, you will be continuously coming back to this particular point to check out what was the 36 outcomes and their sum and all that. Okay, so pause the video, write this down in your notebook, and then move forward with the sub questions of this question. Moving on with the first question, the sum of numbers on the dice is 6. So looking at our total outcomes, we will know that there are 5 outcomes with the sum of number on dice as 6, that is 1 5 2 4 3 3 4 2 5 1, that is total number of 5 outcomes. So the probability will be 5 upon 36. There is not a chance of simplification here, so just let it be. The second question is the sum of numbers on dice is not more than 10. Now if you check the sample space, not more than 10 means everything from sum 2 3 4 5 up to 10. It just excludes sum number 11 and sum 12. So rather than adding all the events from the sum 2 to 10, let's just deduct the events of sum 11 and 12 from the total outcomes. So what I am going to do here, the total outcomes are 36, and the events more than 10 are sum 11 and sum 12, that is 2 plus 1, 3 events. So 36 minus 3 events will make it 33 events. Okay, you can do it simple also, make a total of all the events from the sum 2 3 4 5 up to 10, you will get the same 33 events. I have just deducted the sum events of 11 12 to make it easier. So the probability will be 33 upon 36. As we can simplify it, our answer will be 11 upon 12. Moving on to the question number 3, the sub question number 3, the sum of numbers on dice is multiple of 3. Now this is something which we have already done beforehand. It is a multiple of 3, so sum will be 3 6 9 and 12. So you have to make a total of events which pertain to the sum 3, sum 6, sum 9 and sum 12. When you make a total of all those events, you will get the total outcomes, favorable outcomes as 12. So the probability here will be m upon n, that is 12 upon 36. The simplified value is 1 upon 3. Okay, so do you realize that you constantly need those 36 outcomes in front of you to understand what I am doing here? So even if you have not written it down, just go back, write them down and then come back here to understand it properly, else you will have some gaps in your understanding. The last sum of that question number 2, the product of number on dice is 12. So now this is a bit tricky, but to make it easier, let's just factorize the 12. That is 1, 2, 3, 4, 6, 12. 1 12s are 12, 2 3s are 2 6s are 12, and 3 4s are 12. Now 1 and 12 are not the numbers which are on a dice, but 2 3 4 6 are available on a die. So we can find our favorable outcomes as 2 3 2 6 6 2 3 4 4 3. So 2 6 are 12, 6 2s are 12, 3 4s are 12, and 4 3s are 12. So there are 4 possible outcomes which the product of which is 12. So this is a trick which you can use to simplify your calculations rather than going through all the 36 outcomes to find the product of which element is 12. So probability here will be 4 upon 36, it will be 1 upon 9. So moving on to the third question. One family is randomly selected from families having 2 children. Find the following probabilities. But before that, a family is having 2 children. It could be boy, it could be girl, both could be boys, both could be girls. So the total outcomes here will be baby, that is boy boy, first one is boy, second one is girl, first is girl, second is boy, and both are girls. So total number of outcomes are 4. The first question here is one child is a boy and one child is a girl, but not which is girl, which is boy. So the total number of options which we have, the favorable outcomes are BG or GB, first boy or first girl, that is 2. So the probability here will be 2 upon 4, that is 1 upon 2. Moving on to the second sub question, at least one child is girl. At least means minimum one is girl, more girls are allowed. So the favorable outcomes here will be one girl is BGGB and both girls are GG. So the total favorable outcomes are 3. Your probability will be 3 upon 4. No simplification possible, of course. Moving on to the fourth question in the exercise, one number is selected from the first 100 natural numbers. Find the probability that this number is divisible by 7. Okay, so first of all we have to write down the first 100 natural numbers, that is the sample space 1 2 3 4 dot 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 99 and 100. So as you can see, the total number of possible outcomes are 100. Now the question here is we need to find numbers divisible by 7. So just read the table of 7, that is 7 14 21 up to 98. Now when you divide 98 by 14 7, you get the 14. So total number of outcomes or a favorable number of outcomes here are 14. So when you find the probability 14 upon 100, when you divide both with 2, you get 7 upon 50. So that's the probability that when you select a number out of 100, you will get it in the divisible of 7. So the probability is 7 upon 50. Okay, let us move on. The fifth question, the last question of this tutorial, but this is again a lengthy one. A sample space for a random experiment of selecting numbers is u 1 2 dot 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 120, and all the elementary outcomes are equiprobable. Okay, that is a given thing, of course. Find the probability that selected number is, but before that, first question, a multiple of 3. Okay, the selected number is a multiple of 3. I will name it as event A. That number is a multiple of 3. So when it is a multiple of 3, it becomes a 3 6 9 dot 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 117 120. So 120 divided by 3, when you do, you get the answer 40. So that means 40 events are there between 1 to 120 which are multiple of 3. So the probability here will be 40 favorable outcomes upon 120 total outcomes, and the simplification will be 1 upon 3. So the probability that the selected event is multiple of 3 out of 120 outcomes is 1 upon 3. Second, not a multiple of 3. Now this is an opposite outcome. So actually you can say that this is an event A dash. Okay, that's a complementary event. Event is a multiple of 3, event is not a multiple of 3, that becomes a complementary event A. So numbers which are not part of A but they are part of U. So how you are going to write them down? So everything which is not part of multiple of 3, you have to write it down. So it is 1 2 and not 3, then 4 5 and not 6, likewise, then 118 119 but not 120. Now total outcomes were 120, okay, but the outcomes which were multiple of 3 were 40. So when I remove multiple of 3 outcomes from the total outcomes, I will get the outcomes which are not multiple of 3. Okay, so total outcomes minus the multiple of 3 outcomes gives me the not multiple of 3 outcomes, that is 80. Now solving this sum has two methods. First method, just calculating what we just did now, 80 upon 120, that is 2 upon 3. The second method is which I gave you in the some standard formulas, which was a dash is 1 minus a. Now a is 1 upon 3 that we have just calculated in the previous question. So 1 minus 1 upon 3 will get you 2 upon 3 naturally. So you can use either of these two methods to calculate the complementary event a, that is a dash. The third question here, a multiple of 4. Okay, it is something similar to the first question. I will name it event B, which is number is multiple of 4. So just go with 4, 8, 12, dot, 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 up to 116 and 120. When you divide 120 with 4, you get 30 events. So your favorable outcomes are 30, probability 30 upon 120, that is 1 upon 4. Now, the fourth question here is not a multiple of 4, so it's just like not a multiple of 3. This is the complementary event of the event B. B was multiple of 4, this is not a multiple of 4, that makes it the complementary event B, that is B dash. So we have to take numbers which are not part of B but they are the part of U. So when we write them down like this, it becomes 1 2 3, then not 4, then 5, dot dot dot, up to 119. Just like in the second question, total outcomes are 120 and the outcomes which were the multiple of 4 were 30. So 120 minus 30 will give us the outcomes which were not multiple of 4. Those are the 90 outcomes. So probability B dash is 90 upon 120, that is 3 upon 4. The second method of solving this is using the formula 1 minus B, that is 1 minus 1 upon 4, that is 3 upon 4. Okay, so moving on to the last question of the fifth question as well as this tutorial, a multiple of both 3 and 4. Now it is a multiple of 3 and it is multiple of 4. That means this is an event A intersection B. We are combining the multiple of 3 and 4 both. So technically take an LCM and it becomes 12. So it becomes easier to calculate actually. So the events which are the multiple of 3 and 4 both, that is LCM 12, are 12, 24, 36, dot dot dot, 120. So 120 divided by 12 gets 10 events, and when we find the probability for that, it becomes 10 upon 120, that is 1 upon 12. So my dear students, with this I end our today's tutorial. Next time I will do the next sums, 6 to 7 next sums of the exercise 1.2, but most probably that will be the next week. So my dear students, till then, stay tuned, stay home and stay safe.